So next up, let's just write some steps to solve this type of differential equation. That way you have them somewhere handy to refer back to. So step one, you need to make sure that you're in the standard form, which is dy dx plus sum p of x times y is equal to sum f of x. If you're not already in that form, just rearrange it until you are. And then we're going to compute e to the integral of p of x dx. Since the whole solution depends on p, that's why it's important that you are in that standard form when you pick what p is. And then we're going to multiply both sides of our differential equation by that exponential term we just computed. And after we do that, we have to sort of undo the chain and product rules. On the left-hand side of our ODE. It's kind of those same steps we worked through in that intuition part of the last video. So then the ODE should end up in this form, which is that the left side becomes d dx of e to integral p of x dx times y. And then on the right side, you've multiplied by that e. Oh no, I forgot my equal sign. And you don't need to re-show me that like chain product rule thing every time. You can just tell me that you know that's what's happening and it ends up in that form. But then after that, you're just going to go ahead and integrate both sides. With respect to their variables. So the left side is always easier than the right side here. I do want you to remember that we need to be careful to include constants so that we can take care of our initial conditions. And again, we're going to have the option of doing constants or definite integrals. And then you're just going to rearrange so that you have your solution y equal to some stuff if you can. And then, if necessary, solve for your unknown constants if you didn't take care of them in the definite integrals or if you're not solving just a general solution type problem. I really want you to note that I care about the process. Not the formula. So the thing that makes this a differential equations problem is that you start from a differential equation and you learn how to manipulate it in a way that it becomes a calculus problem. To me, if you memorize this formula and then plug it in, all you've shown me is that you can do Calc 1, not differential equations. So please do not use that formula. I will only see if you use it on an exam, but it would be good practice in your homework and whatnot to also not use the formula, because I will not give you credit for it. So please try to pay attention to how this process works, because it really is kind of like a generalizable approach that we're taking to a lot of problems here. And I think I know this is a bit short, but I want to no, it's okay. We'll go ahead and do the start of this example for the general solution, and then we'll do all the initial conditions in the next video. So let's go ahead and move on to our first example of actually applying this type of solution. We're going to be looking at finding the general solution to dy dx minus 3y is equal to 6. So this problem is already in your standard form. And here our p of x is equal to minus 3, and our f of x is equal to 6. So the p is the thing that multiplies y, and the f is the thing that's on the right. Then we also need to make sure that we want to solve e to integral p of x. So integral of p of x dx is going to be integral of minus 3 dx, it's just minus 3x. So e to integral p of x dx, which we needed to solve, is e to minus 3x. That's the thing that we're going to multiply both sides of our differential equation. So at this point, I'm kind of on to step 3. I had the standard form, I computed that e to integral p of x dx, and now I've put it on both sides of my equation. And here's the part where I have to, note or remember that I can undo my chain and product rules on this left side to sort of pull out that one thing that's really easy to integrate. So the right side is unchanged, but on the left side, we've thought about distributing e to minus 3x through, thinking about the chain rule, and then the product rule, and eventually we're looking at just the derivative of e to minus 3x times y. And then at this point, once we're in this form, where the left side is all one derivative together, we can go ahead and integrate everything. So we integrate by moving the dx over to the right side so that we have something to integrate with respect to. On the left side, we're just integrating with respect to this thing in the square brackets. So it's kind of like if you had integral dt is equal to t. Integral of d e to minus 3xy is just e to minus 3xy. And then integrating the right side is just evaluating a negative exponential integral. So it's going to be 6 divided by whatever's inside the exponent, and then the exponent stays unchanged. And we remember that we have an unknown constant, and you can think about that as being the combination of the constant on the left and the right. Or we can go ahead and solve for the solution by dividing by e to minus 3x or multiplying by e to 3x. And so we've got minus 2 plus c e to 3x in the end. And that's how we're going to solve these linear equations. So in the next video, we'll deal with the c in an initial value problem. But for right now, just make sure you have all these steps down and that you're ready to work on it for your participation problem.